Okay, so for the second video assignment, I plan to address the second question here of what happens when three reflections had parallel lines of reflection with no repeated lines. So for this to be possible, to have three reflections across parallel lines, all of the lines have to be unique because there's no repeated lines, so that means there has to be three lines to do this. So to show this more visually, we'll go to GeoGebra to make it look nicer. We already have set up the shape we're going to be reflecting and three parallel lines of reflection. Our shape is a triangle with vertices I, G, H, I at -3, 3, G at -3, 1, and H at -4, 2. And our three lines of reflections, all unique, will be at x equals -2, x equals 1, and x equals 4. And these were just randomly chosen. They have no really special meaning, but to demonstrate what can happen with the unique lines of reflection. So, to begin, we first note that since we cannot use the same line twice, there are 6 or 3 factorial ways that we can reflect this triangle across these lines, in a unique pattern, such that all these lines are used but none are repeated. We can do reflected across the first one first, the second one, and then the third, or we could do the first and the third and then the second, or we could do the second, the first and the third, or the second, the third and the first, or the third, the first and the second, and then or the third, the second, and the first. And my claim before we do any examples is that if we do any of those that I just mentioned, it will result in a reflection and not a translation. And my further hypothesis, I guess, would be as long as you reflect an object such as this triangle an odd number of times, it will result in a reflection, and if you do it an even number of times, it will result in a translation. And so we'll begin by selecting the reflect tool, reflect about a line tool, and grab the triangle, and we'll kind of use, I guess, the method of exhaustion when proving what I just stated, that no matter which way we do this, as long as we do all the lines in a unique way, we don't repeat any lines, I should say, it will result in a reflection. So let's do the first one I mentioned, and we'll go right down the line, reflect across this line, and then this line. So we grab the triangle, we'll reflect. Okay, we got a reflection. Grab it again, reflect across the second line. Okay, we got a translation. And grab it again and reflect across the third one. So as you can see, it resulted ultimately, after 3 reflections across 3 unique lines, in a reflection. And as I stated earlier, there are 5 more unique ways we could have done this. So, backtracking, once again, the first, we'll grab it, we'll do the first line. Instead of doing the second line, we'll grab it, and we will translate it across the third line, resulting in a translation, an even number of reflections, translation. Grab it again, reflect it across the one, our last unique line that we haven't reflected across yet, the second one. And I believe it moved off screen here, but as you can see, it resulted in a reflection, ultimately across the line x equals -5. So that still holds for what I was saying, that an odd number of reflections will yield, odd number of reflections will yield a reflection. So that was the 2 of the 6 down. Going for the third possibility, we'll grab our shape again. We'll reflect it across the middle line. Reflection. Grab it again, first line. Shot off screen again, I believe. Translation. Grab it again. Over the third line, move our cursor once again, and we got a reflection, as you could see there. Our final triangle, our original triangle. Okay, halfway through of the all possible things that could happen. Once again, grab our triangle. Over the second line, reflection. Over the third line, translation. Over the first, grab the triangle, and over the first line, a little off screen again. As you can see, once again, reflection, resulting in actually the same one that we just had a while back. But ultimately, like I said, a reflection, odd number of reflections yield a reflection, even number yields, basically a translation. So going back again, we'll grab our shape, grab our object, use the reflect about a line tool. We're in the home stretch with the final two possibilities over 3 lines, uniquely reflected. Going across the third, shot off screen, grab our reflection tool again, go across the first, off screen again. So far 2 reflections, and it's a translation. Grab it again, and we'll reflect it across the second line, the middle line. Gotta grab it here, and we will. All right, a little tricky here. All right, and reflect it across the final second line. Move over, see our results. Where is it at? There it is. LGH, all triple prime, results in a reflection. And then the final possibility with 3 unique lines of reflection will be when we do the opposite of what we started with. Instead of 1, 2, 3, go 3, 2, 1, and we get ultimately a reflection, but just to show, reflect across the third, off screen. Let's move it over. So far it's a reflection. The second one will be a translation, relative to the first object, not this object, of course. Reflect across the second one there. Over here, the translation went relative to the first. And then our final reflection across the second, or the first line, will yield a reflection. Where is it at? Over here? No, over here. And as you can see, comparing those two, it is a reflection of the first. So, like I said, the 6 possibilities of reflecting across 3 lines uniquely, 3 parallel lines uniquely, will yield a reflection always. And even more general, an odd number of reflections across unique lines will yield a reflection. An even number of reflections across unique parallel lines will yield translation relative to the starting position of the object you began with.